Shahjahan. Chemistry is a very elaborate subject. Many topics are there. That one topic, Dienes topics. Dienes, introductions, classification, differences between isolated and conjugated dienes, structure and properties, stability of the dienes. These are the topics only discussed about today. Carefully listen. Dienes introduction. Various types of the definitions are there. All of you coming for the same meaning. First one, open chain alkanes which contain two double bonds on the carbon chain are called dienes or diolefins. Another definition, diene is an unsaturated compound containing two double bonds between carbon atoms. Another definition, dienes are alkanes containing two C double bond C double bonds. These have general formula CnH2n-2 and are isomeric with alkanes. You can say alkanes means carbon is coming for the single bond. Alkanes carbon coming for the double bonds. Alkynes carbon it should be coming for the triple bonds. So you already know saturated unsaturated hydrocarbons. This is coming from the types of the hydrocarbons. Today's only discuss about further in alkanes. Why I am saying carbon and carbon is coming further in a double bond. That only is a main theme of this topic. Classification of the dienes. Dienes are classified into three classes depending upon the arrangements of the double bonds on the carbon chain. That means is a different arrangements is coming further in a double bonds of the carbon chain based upon classification of three types. First one is a conjugated dienes, isolated dienes, cumulative dienes. First one, conjugated dienes. What is the conjugated dienes? Conjugated dienes, which the two double bonds are separated by the single bond. How do I say? There is a alternate single bonds and double bonds. Look at the two examples are there 1,3-butadiene, 2,4-hexadienes. In a 1,3-butadiene, CH2 double bond CH, single bond CH, double bond CH2. The double bonds is coming for that in a alternate places. Is a center of the bond is coming for the single bond. So alternatively double bond, single bond, double bond. So this is a good example for the 1,3-butadiene and another same example for this type of the dienes 2,4-hexadienes. Also you can look at CH3 single bond CH double bond CH single bond CH double bond CH single bond CH3. This is another one example for the conjugated dienes. You can just look at a single bond, double bond, single bond, double bond, single bond. So this is a alternating single bond and double bonds is coming for the conjugated dienes. Next, isolated dienes. These types of the dienes, a double bond is present, but more than one single bond is separated. That means the single bonds is present in a more than one. The double bond is separated. For example, 1,4-pentadiene, 1,5-hexadienes. You can see this types of the isolated dienes is coming. 1,4-pentadiene, the double bond is separated for the two single bonds. The 1,5-hexadienes, the double bond is separated for the three single bonds are present. So there's more than one single bond is separated for the double bonds. These types of the dienes. Next one, cumulative dienes. The cumulative dienes, the double bond are present between the successive carbon atom. Successive carbon atom means is coming for the continuously coming the double bonds. So that is a successive carbon atom. These types of the dienes is also called allenes. Example 1,2-propanadiene, 1,2-butadiene. Example for the this cumulative dienes. Just you look at the two examples. Is a continuously coming for the double bonds. The 1,2-butadiene and 1,2-pentadienes. So these types of the examples cumulative dienes. Differences between isolated and conjugated dienes. Addition reactions isolated take place the normal addition reactions. Conjugated dienes abnormal addition reaction. For example, take place for the 1,4 addition of the butadiene. Polymerization reactions is not take place for the isolated diene, and the conjugated dienes is a take place for the polymerization reaction. Diels order reaction not take place for the isolated dienes, but a conjugated diene is a Diels order reaction going. And SO2 reactions is going for that in a not give the cyclic sulfones, isolated dienes, but conjugated dienes they give for the cyclosulfones. The structure of the dienes. How to coming for the structures in isolated dienes, conjugated dienes, cumulative dienes. Just you can see isolated dienes. Isolated dienes. Look at the double bonds. Coming for that in a center point. Yes, two single bonds is coming. Next one conjugated dienes is coming for that in a double bond is alternatively coming in a present in a single bond in a center. Cumulative dienes just can look at in a coming for the in a simultaneously coming for the double bonds in a carbon chain. So this is a structure of the dienes. Properties of dienes. First one physical property, next one chemical property. First we discuss about the physical properties. Physical properties, it is a colorless gas, melting point 108 degrees Celsius, boiling point minus 4.4 degrees Celsius. It is insoluble in water. These are the physical properties. Chemical properties, addition reactions, 1,2 addition reactions with addition of hydrogen. Taken in a 1,3-butadiene, react with the hydrogen in the presence of nickel, it gives for the product. 1,3-butadiene example, react with the hydrogen. First carbon and second carbon only reaction take place. First carbon CH2 is a product is a CH3. Second carbon CH is a product is a CH2. It gives for the in a product side you can see CH2 double bond CH single bond CH2 single bond CH3. This is a 1,2 addition reaction. Next one is a 1,4 addition. So first carbon and fourth carbon only reactions take place. Taken in a hydrogen. Two hydrogen take place. React with the first carbon and fourth carbon. Same reactant is taken, but reaction only first and fourth carbon. The presence of nickel. So product is a CH3 single bond CH double bond CH2 single bond CH3. This is addition reaction of hydrogen. Next one is addition reaction of halogens. Taken in a halogen compound in Cl2. Same reactant is taken 1,3-butadiene. So 1,2 addition is a halogens chlorine taken. It gives for the 1,2-dichloro 3-butane. So first carbon and second carbon it should be added the chlorine atoms. So this is a 1,2 addition. Next halogen react with 1,3-butadiene, but react with the first and fourth carbon. In case I am taken for that the halogen bromine. Two bromine react with the first carbon and fourth carbon. So it gives for the product is a 1,4-dibromo 2-butene. A molecular formula CH2Br. This is fourth carbon. CH double bond CH single bond CH3Br near first carbon. So 1 and fourth carbon, first carbon and fourth carbon, it should be Br is added. So product is a 1,4 dibromo 2-butene. Next one is a addition with the halogen acids. Hydrogen bromide it should be taken, the reactant with 1,3-butadiene. It gives for the 2-bromo 3-butene is a product. First and second carbon should be added for that in a hydrogen bromide. This is a addition reaction of halogens acid. It gives for that in a 2-bromo 3-butene. Next one is a addition with the halogen acids in a 1,4 addition. 1,4 addition means 1 and 4th carbon taken in a hydrogen bromide. So it gives for the CH2Br CH double bond CH single bond CH3. This is a addition with the halogen acid for 1,4 addition. Next one is a addition reaction with SO2. 1,4 addition taken for that in a diene. SO2 react with cyclic sulfones, it should be formed. Look at that example. Next one is a polymerization reaction. Same one, 1,4 addition. Take a peroxide in the presence, it should be give for that in a polybutadienes. This is a polymerization reactions take place in a 1,4 addition. Diels order reaction taken in a dienes and dienophil. That means ethylene. You react with one of the diene. It gives for that in a adduct compound cyclohexane. You can see the diene react with the dienophil. It gives a adduct compound of the cyclohexane. How to bond breaks of this compound is given for that in a equation. The mechanism of the Diels order reaction. The electron flows for that in a two directions or two flows. In a center product, that is a center of I give, that is a product. In a left hand and right hand direction is a give for that in a reactant. The places here is a variable. Just you can see for that in a first one. In a first one taken in a 1,3-butadiene and a dienophil already I have taken. So breaks first carbon 1, 2, 3, 4, 5, 6. 1, 2, 3, 4 is here given in a 1,3-butadiene. Dienophil is a fifth and sixth carbon. Then break the bonds. The dienophil break the double bonds. It forms a one single bond. Next, that is a break the double bond means in a fifth and sixth carbon is having double bond. One breaks a double bond, it gives for the single bond. Next, third and fourth or third having for that one double bonds having, that means double one pi bond and single bond that breaks. It's that double bond is going for that in a third and second places. Next, second and first places having for that in a double bond. This going for that in a breaks and it forms a new single sigma bonds is created. That one is a breaks. How to carbon chain is breaks. It forms a product attack form of the product. So A breaks carbon 1 and carbon 2. Carbon 1 and carbon 2 having a pi bond. It forms a carbon 1 and 6 is a forms a one of the bond of sigma. Next one I mentioned about for the B carbon 5 and carbon 6 having for that in a double bond, that is a breaks. It forms a carbon 4 and carbon 5. it forms a one of the single sigma bond. Next one is a breaks the carbon 3 and carbon 4, it forms a carbon 2 and carbon 3, it forms a newly created in a pi bond. This is the direction of the clockwise flow is. Next, counterclockwise, how to break the bonds, same product of the adduct compound. You can look at the carbon 1 and carbon 2. Carbon 1 and carbon 2 having for that in a double bond, that also containing on one of the pi bond. The pi bond is breaks, you form a carbon 2 and carbon 3 also form a pi bond. That is mentioned about for A. Next, mention about for the B, break the carbon 3 and carbon 4, double bond having, one is a pi bond, that pi bond is breaks, it forms a carbon 4 and carbon 5, that is a B, that is a newly formed a sigma bond. Next, carbon 5 and carbon 6 are also containing for the two double bonds, one is a pi bond, another one is a sigma bond. So it forms a carbon 1 and 2 carbon 6, carbon 1 to carbon 6, it form a newly bonded for the sigma bonds. So this is a product of the cyclohexane. This is a counterclockwise flowing for that in a form. Next one is a clockwise forms the same product, you should adapt product is a form. This is for the Diels-Order reaction mechanism. Stability of the dienes. Which dienes is a more stable? Cumulative or conjugative or isolated dienes? Already know for that what is the differences between for the three categories. So I can say conjugated diene is a more stable. How to I say some of the stability parameters are there, that one evidence of the stable for the conjugated dienes. You can look at that 1,3-butadiene and 1,3-pentadienes. So in A and B, in going for that in a bonds are shifted for that in a plus and minus charges in a right hand direction. Right hand direction, first, second, third, fourth carbon. 1,3-butadiene is going for that in a, you can moving for that in a bonds. The first carbon is going for that in a breaks with one second. So plus charges is created and a minus charge created. Next one is a plus charge created as a shifted. Next one is a minus charge created. Minus charge created and a plus charge created. This is for that in A. I will explain for that in a B. Isomeric forms of the 1,3-butadienes. In right hand direction, this is shifted for that in a bonds. A double bond breaks. So plus minus plus minus. I will give for that in a one of the hyper conjugation forms of the this one. So this is a one of the resonance structure is a form in a right hand direction. And also 1,3-butadiene in left hand direction is going, bonds is breaks, is shifted for that in a bonds. So shifted bonds means you can sign, so you get for that in a minus plus minus plus. So this is one of the another resonance structure is formed for the hyperconjugation formed. So this is a another one resonance structure is formed. So more resonance structure is getting, that compound is a more stable. So the conjugated diene is a more resonance structure is formed, so more stable. Bond length. 1,3-butadiene is a double bond. Two double bonds having. So two double bonds is a 1.3 Armstrongs. Another one is a single bonding is a 1.54 Armstrongs are there. This is a normally having for the bond length. But in a carbon chain, if a bonds is breaks, the double bonds, that means unsaturated carbon atom is a bond length is a created. How much bond length is created and shifted further in a right and to left direction, left and to right directions. The bonds is going for the another carbon atom. So in a unsaturated carbon atom bond length is a 1.47 Armstrong. In a right hand direction, also left hand direction. So bond length is a stabilized unsaturated carbon atom. Resonance in conjugated dienes. I will show that cumulative dienes, conjugated dienes, isolated dienes. Just one look out. In a cumulative dienes, you can listen. The cumulative diene CH2 double bond C double bond CH2. So the first, second and third carbon. The first carbon is a double bond is break. So it breaks that, it forms a plus charge and create further in a minus charge. This is a product. Another one is a, it form a carbene form. The carbene form is a no hyperconjugation. So carbene form is also unstable. So cumulative diene is a unstable. Another one is here, you can left hand side you can see isolated dienes. CH2 double bond CH, single bond CH2, single bond CH, double bond CH2. You can first and second, third, fourth, fifth, and the first one you can carbon CH2 double bond is breaks. You can what happen? The CH2 plus single bond CH minus. Another one is here, fourth and fifth carbon is a double bond is breaks. It forms here CH is a plus, CH2 is a minus. You can form the next one carbon. So that place is here giving for that in a second and fourth carbon you form a one ring. That I give for that in arrow mark. Slight lightly you can draw, but you can second and fourth carbon it should be one of the compound is formed. So that is a 3-member cyclic ring is formed. So this is a unstable. So isolated diene is a unstable. Why? Not a, when the hyperconjugation cannot be created. Next one is a conjugated diene. Conjugated diene CH2 double bond CH, single bond CH, double bond CH2. Yeah, first and second carbon having for the double bond is breaks. It gives for that in a plus and minus. Next carbon, third and fourth also break that bonds. It forms a plus and minus. So more stable. Which one is a forms for that in a more resonance structure is getting. So this also evidence hyperconjugation molecules is formed. So the conjugated diene is a more stable than other dienes. Last one, evidence of the conjugated diene is a more stable. Last evidence, heat of the hydrogenation. Heat of the hydrogenation of dienes should be heated. The presence of hydrogen, 4 moles of the hydrogen heated. In the cumulative dienes, it gives for the forms one of the product is forms also form the heat. 70 kilocalories of the heat is generated. Next one is isolated dienes also react with hydrogenation with hydrogen form of the one of the product. It also heat is produced for that in a 60 kilocalories is formed. Next one conjugated dienes. The conjugated dienes also react with hydrogen. It forms of the product. It also plus 57 kilocalories of the heat is generated. So cumulative diene is 70 kilocalories of the heat generated. Conjugated diene is 57 kilocalories of the heat is produced. Isolated diene is 60 kilocalories of the heat is produced. Note that which one is a lowest heat is produced, that only is a more stable. So less heat hydrogenation is more stable. So these three dienes, which one is a less of the heat is generated, that is conjugated diene. Only 57 kilocalories is heat is produced. So this is a more stable. Next one is a 60 calories is a isolated diene. Another one is a cumulative diene is a last category. So the categories wise I will give which one is a more stable. Conjugated diene is a more stable than for the isolated and cumulative dienes. Giving for that in a order, conjugated dienes, isolated dienes is a cumulative dienes. Is a stable is a more stable is a conjugated dienes. So heat hydrogenation is another evidence of the stability parameters is given. So conjugated diene is more stable than other dienes.